Hi, in today's video I'm going to be covering the FFmpeg Rust scripts, which are a Rust port of my FFmpeg shell scripts that I made several years ago. So these are Rust scripts that I got some help from Gemini to create. Let me just refresh my memory on my show notes. Now basically what these are, as I said, they are the existing FFmpeg shell scripts converted to Rust with a bit of help from Gemini to replace the shell scripts with the Rust code. Now these are using the existing FFmpeg code and logic, so it's not technically vibe coded. I just got some help from Gemini in the conversion process from the shell scripts to the Rust code. We have 32 scripts split into various categories for simple editing tasks. It works on Linux, NixOS, macOS X, Windows and FreeBSD. You don't need Rust installed on Linux, NixOS or Windows. They're statically compiled binaries for Linux, NixOS and exe files for Windows. Mac and FreeBSD users have to install Rust and compile the binaries because I can't compile them on NixOS because of missing SDK and header files on NixOS. The advantage of Rust is speed and cross-platform. They're small file size in just over 1 meg on Linux and 2 meg for the Windows exe files. And we have minimal external dependencies, which are FFmpeg, yt-dlp, Dino and FD for batch processing. We've got an extensive README, which is almost 4,000 lines long and fully commented source code. So let's have a look at the actual project, and I'll go through and show you the scripts. So this is the project, FFmpeg Rust Scripts, and what you'll see here is the files that are included. This is released under a BSD 3 license, and we have the releases over here. If I just come across to the releases, so what you'll see down here is the Linux, NixOS and Windows executables. You can ignore the source code, don't download that. We also have SHA checksums, so you can check the integrity of the release when you download it. So let's have a look at the project. So this is a collection of FFmpeg Rust scripts, and as I said, the advantage of using Rust is it's much faster than using shell scripts. And what I've done is actually break the scripts down into particular categories of scene detection, trimming and clipping, chapters and metadata, overlays and transition, visualization and analysis, conversions and extras. So as I said, the supported operating systems are NixOS, Linux, so that's all your Linux, Ubuntu, Arch, Fedora, what have you, Windows 10, 11, macOS X and FreeBSD. As I said, we've got statically compiled binaries for Linux, NixOS and Windows, which means you don't have to have Rust installed. But as I said, because I can't compile the binaries for macOS X and FreeBSD, you do need to download the project with Git and build it using Rust, but that doesn't actually take very long. So what we've got here is the installation instructions for NixOS, Linux, Windows, Mac, FreeBSD, and then the list of these scripts broken down into categories. What I'm going to do is actually take you through the scripts and actually demonstrate them for you in the terminal. So first of all, what we've got is the trimming and clipping. So what we have here is trim clip 2, trim remote clip, trim short, clip time, scene cut 2 and combine clips. So clicking one of those headers will automatically jump to that section. So first of all, what we have is trim clip. And what this does is this allows you to trim a clip with millisecond accuracy by providing a start time with the -s option and the time in hours, minutes, seconds, and optionally milliseconds. the -I option and the video or audio file you want to process, so like a MP4, MKV, MOV, WebM, or audio files, WAV, MP3, OGG, MP4A, that sort of thing. And then we have the to option, and this is the number of seconds after the start time. So for example, this command here will create a clip starting at 30 seconds to 1 minute. So that's going to start at 30 seconds and the clip duration is going to be 30 seconds. And what we can do is we also have the option to batch process the files using FD. FD is a Rust version of the find command, which is much faster and has a much simpler syntax. So as you can see here, we can batch trim all of the MP4s, MKVs, MP3s in the current directory. And then what we have here is the help option. So when all of these scripts support a -H flag, and this will output the help. And the help is standardized across all the scripts. And what it will do is it will tell you what the script does, give you the usage, the options, which are the flags that you can pass to the script. It will give you an example, and it will tell you the dependencies required for the script. So let's have a look at the trim clips script first of all. So what I've done here is actually create a list of directories for all of the scripts so that I can easily demo them for you. So what I'm going to do is come into trim clip, and what you'll see here is we have a copy of Big Buck Bunny. So here we go, here's Big Buck Bunny. So what I want to do is trim a section of this clip by specifying a start time and a duration for the clip. So let's just come through here. Okay, so what we got here is, let's just do, say, 2 minutes to 2 minutes 30. So what we do is run trim clip -H, and as you can see here, this is the help. So the start option, the in file, and the duration. So again, here it specifies the duration is the number of seconds after the start time. We just run trim clip start hours, minutes, seconds. So that's 2. Give it the file, Big Buck Bunny. And we'll create a 30-second clip. Okay, there we go. So as you can see, what we have here is the output file name. So the output file name is the video file here, followed by the start time and the end time of the clip that we created. Now on Linux, the timestamp is separated by colons, but on Windows it's separated by a dash, and the reason for that is you can't use colons in file names on Windows. So if we just play that clip, what you see here is we have a 30-second clip. So the purpose of that script is that this is when you want to create an exact duration of a clip. You just want to specify the start time and then a duration for the clip. Okay, so let's come on to the next script. So trim clip 2. So this is slightly different in it that it takes a start time with the -S option, the -I option for the file, and a -T option, which is the position in the video you want to trim to. So in this example here, what we have is a start time of 30 seconds to 1 minute 30. And what this will do is this will create a 1 minute clip starting at 30 seconds and ending at 1 minute 30. So let's come in here. So trim clip 2. Again, we've got Big Buck Bunny, and the reason I'm using Big Buck Bunny is because it's not subject to copyright issues. So what we can do is run trim clip 2-h to specify the help. Okay, it will give you all the options here. So trim clip 2 start, and we'll just use the example Big Buck Bunny to okay. And as you can see, all the scripts provide FFmpeg output, and the reason for that is because you actually want to see what's going on as it's creating the script, rather than an empty output and you're wondering, is the script actually working? So you can see here the timestamp is changing up to 60 seconds. And if I list that here, what you'll see is the file name contains the original file we processed, followed by the start time and the end time. And the reason for this is so that you can easily identify where you've clipped the video from, basically. Okay, so play that, and you'll see that this is a 1-minute clip. Okay. Right. Again, this works with FD, so that you can batch process all the clips in the current directory. As I said, it works with video files or audio files, and FD is a much simpler version of find with a much easier to use syntax. You can see here the only option we're changing here with FD after the -e option is the name of the extension of the file that we want to process, for example MP4, MKV, MP3. Okay, trim remote clip. Now what this does is this allows you to download and trim a specific segment of an online video without downloading the entire file, and it uses yt-dlp and Dino to fetch the stream and FFmpeg to extract the clip with millisecond accuracy. So this is the format of the script. We've got trim remote clip -s, the start time, -i, the URL, -t, and the position you want to create the clip from. So what I have here, if I come into the trim remote clip, okay, so what I've done ahead of time is actually taken the URL for Big Buck Bunny on archive.org. Let me just. So what you can see here is we've got trim remote clip, start time of 30 seconds to 1 minute, -i, and then the URL. And what this will do is it will create a 30-second clip starting at 30 seconds and ending at 1 minute. Okay, so trim remote clip, and because this uses yt-dlp, it works with all of the sites supported by yt-dlp. And note, you do need Dino installed for yt-dlp, and I provide instructions on how to set that up on the various operating systems. The way this works is it will basically download the highest quality available, and you can use your yt-dlp config to specify the quality that you want to download. For example, if there is a 4K video and you just want to download a 1080p clip, you can specify that in your yt-dlp config by looking at the configuration options for yt-dlp. So just press return here, give it a second, and what it's going to do is fetch the stream and then trim it. Now this script works with other video files or audio files, and it works with videos that have a single combined audio and video stream, or dash streams that have a separate audio and video streams. So as you can see here, what it does is it uses the input file name and appends the portion of the clip that you have created. For example, here 30 seconds to 1 minute, and if I play that, you can see this is a particularly small clip. It's only 4:16, but you can see that this is a 30-second clip. Okay, and this isn't really designed to work with find, because you're using URLs. Okay, trim short. What this does is this creates a vertical 9:16 clip for YouTube Shorts and TikTok. And basically what it does is, by default, it will create a 60-second clip, but you can override the duration of the clip that you want to create to make it longer or shorter. We also have a X option. And what this allows you to do is specify the position in the video that you want to create the short from. So 0, 25, 50, 75, 100. 0 being the left side of the frame, 100 being the right side of the frame, and 50, which is the default as the center. So again, what we do is we run the yep, let me just check. Trim short. Okay. So again, we've got Big Buck Bunny here. So trim short -H. And again, the help is all standardized so that it's familiar to you, basically. So what we can see here is the options we have. In file, start, the end, the X position, the out file, H and V, the help and version. And what it will tell you here is the dependencies, and it will give you an example. So what we want to do is create a TikTok short using Big Buck Bunny. So trim short. So what we'll do is we'll pick let's pick 5 minutes. So we'll start at 5 minutes. So again, hours, minutes, seconds. And if you just want to use the default 60 seconds, you just use this. It will do something in a second, hopefully. Yeah. Now, note what a lot of these scripts do, and I designed specifically the output files this way, is that they will actually contain the options that you pass to the script in the output file name, so that you can easily identify the options that you have used in the script. So you can see here, this has created a short from 5 minutes to 6 minutes. So if I play that and put it full screen, you can see here we got a TikTok short or YouTube short. Okay, so let's do the same thing but use the X option. So what we can do is we can specify the X option and the position that we want to create the clip from. Again, 0, 25, 50, which is a default, 75 or 100 for the right of the frame. So if we specify X, what it's going to do is it's going to create a clip that is 60 seconds long and starts on the left hand side of the frame. And this is useful because you may have a video of you dancing about like an idiot in the left-hand side of the frame, and that's the bit you want to put on TikTok so that everyone thinks you're an idiot. Okay, so you can see this is whirring away, and you can see the timestamps updating. So what we'll do is, after this one, we will use the -T option to create a shorter clip. Okay, so what you'll notice here is the file name has the -X0 option appended to the file name, and this is so that you can identify from the file name the position in the video that you've actually taken that from. So this is the exact same video, but it's taken from the left-hand side of the frame instead of the center. Okay. You get the gist. So let's do the same thing, but specify a length of the video. So -T, what we want to do is specify a position in the video. So let's say we just want a 10-second video. So this is going to create a video starting at 5 minutes and ending at 5 minutes 10. And again, the option after the script will be added to the file name. Just leave it, there we go. So we can see here, should have, no, did it not append that? Okay, it didn't append the -T option because the -T option is actually specifying the duration, as you can see here, whereas the X option is an option that sets the position. So if we run Big Buck Bunny short, that'll be a 10-second clip. Okay. Okay, so again, trim short -H. As you can see, we've got sensible script options here. We've got a default of 60 seconds, which I believe is the default for YouTube Shorts, but you can override that with the -T option, and the -X option is to set the position, and all the scripts have automatic file names if you don't specify a -O option to provide a custom file name. Okay, so next script, again, this is designed to work with FD as well, so this allows you to batch process all of the different types of video that you got in a current directory. Okay, so clip time. So what this does is, this is so that you can actually batch cut a video. So what you've got is the trim clip 2 script, where you can execute it once to extract a single portion of the clip. What the clip time script does is it takes a text file with timestamps like this, and it converts the text file with the timestamps to a file that can be used with the next script, which is scene cut 2, which will batch process the file and trim all of those timestamps out of a video. So if I come across into, have I got clip time? Or add clip time somewhere. Oh yeah, did I? Scene cut 2, yeah, no, I put it in scene cut 2 because the clip time script works with the scene cut 2 script, and it's a 2-stage process. So we have the timestamps here. So what I'm going to do is come into scene cut 2 and run clip time -h, and it'll say it takes an input file and optionally an output file for the cut list. So if we just run clip time and give it the timestamps, what you'll see is it's created a file name with -cut list appended to it. So if I have a look at this, what you'll see is it calculates the duration of the clips, basically. So if I let me desktop scene cut to timestamp. So what we can see here is we got different timestamps: 10 seconds, 20 seconds, 30 seconds, 45 seconds. And what the script does is it's subtracting the end time from the start time. So this first clip is going to be 10 seconds, and the second clip from 30 seconds to 45 seconds will be 15 seconds. So you can see here 10 seconds to 10 seconds, 1 minute 30 to for 15 seconds. Yep, okay, yeah. So 1 minute 30 to 1 minute 45. So what we do is, after we've done the clip time script, we run scene cut 2. And again, here it's showing you the format of the input that it takes. And then basically we just run scene cut 2 -i with the video and -c with the cut list. So the cut list is this file, scene cut 2 -h. Okay, so scene cut 2 -i, big buck bunny, the cut list, which is timestamp -cut list. And what it's going to do is it's going to go through and create those clips. So this is how you can create multiple clips from a list of timestamps. Okay, so what you'll see here is this is create the first clip from 10 seconds to 20 seconds, and the second clip from 1 minute 30 to 1 minute 45. Okay, I'm just going to rattle through these because there's a few to get through, and then I'll show you the source code. Okay, so combine clips. What this does is this takes a video file and a audio file and then combines them together. So you run combine clips -i, the video file -a, and the audio file, and optionally a -o option for the custom file name. And this also works with FD as well. So if I come out here, combine clips. So in this directory, what I have is a audio file and a video file, and I want to combine them together. So I'm going to come out into there, scene combine clips -h. That's going to give you the help. Always a good idea to run the script with the -h option just to refresh your memory. So combine clips -i, video -a, and the audio file. And you can see it's basically instant. So let me play you the video file first of all. Okay. Then I'll play you the audio file.
At the left we can see at the right we can see the hat snarlers.
So that's some audio from Elephant's Dream, which is another Blender video. And you can see here I've got video -combined and then the timestamp. So video -combined.
At the left we can see at the right we can see the hat snarlers.
Okay, you get the idea. And let me have some tea before it gets cold. Cold tea is terrible. Okay. So again, read the documentation. As I said, the documentation is almost 4,000 lines long, so pretty comprehensive. So you can see here what you can actually do is you can actually run fd and batch process all of the files, but they need to be named the same for it to pick it up. So like file1.mp4, file1.wav, file2.mp4, file2.wav. You get the idea. So visualization and analysis. So what we have here is the waveform script. So let me come across into waveform, and again, Big Buck Bunny, waveform-h, and these are the options that you can use. It takes the -i option and a video or audio file. You can specify the color, the width, the height, the format. All the scripts that work with images are set to a default of using JPEG because it's smaller, it's faster, and it's probably something you're going to put on the web. But you also have the option to use PNG files, but the file size will be bigger and it will take longer to process them. So let's just use the default waveform-i Big Buck Bunny, and what it's going to do is create a file with -waveform.jpg, and if I come across into here and open this up, you will see this is a waveform of the audio of Big Buck Bunny, and as I said, you can specify different colors, height and width, PNG, JPEG, as you like. Okay. So that's the waveform. This also works with FD, so you can create waveforms for all of the audio or video files in the current directory as well. Scopes. You're going to like this one. So if you ever used a video editor like DaVinci Resolve or Final Cut Pro, you'll know that you have scopes, vector scopes, to actually display information about the video. What we have here is several different options. We got -i, -o, p, s, w, and v, and these all display different types of vector scopes. So scopes, Big Buck Bunny, so scopes -h, and what this will do is it will actually show you the options. Now, this is the one script that has a change to it, in that to see the version you use capital V instead of lowercase v, and that's because we're using the -v option to display the vector scope. So let's go through the different scopes. We've got I, O, P, S, W, V. So scopes -i. Okay. You can see here we got scopes showing, I think, which one was this? This is a histogram parade. The next one is a RGB overlay. So scopes O Big Buck Bunny. So this is an RGB overlay here. Yeah. Next one is P, which is a RGB parade waveform. Scopes P. Okay. As you can see, the video comes down, the scopes change. Next one is S. This is the RGB overlay and parade stacked together. So scopes -s. And then finally we have the vector scope with the -v option, and this will show you the you can see here this is moving towards the green because there's a lot of green in this, so this will show you the a color representation of the videos. You can see there's blue here. Yeah, you get the idea. Okay, so that's scopes. Okay, ebu-meter. What this does is this shows the audio levels according to the EBU R128 standard, which is a loudness requirement monitoring LUFS, which is loudness units relative to full scale. And this is useful to check the audio levels for audio and video if you're going to upload it to the web. And it has a -T option where you can specify the actual LUFS value you're targeting. So if we come back out to ebu-meter, ebu-meter-h, you can see here we've got a target level, and the target is set to -16, which I believe is the requirement for YouTube. So we can do, just give it the -I option. Now this script actually uses FFmpeg, and you need to, at least on Linux, you actually have to specify in your shell configuration file an option if you're using Wayland to get FFmpeg to work correctly, and that is in the documentation for setting this up on Linux and Freebsd, and I'll cover those in a later video. I believe you don't have to set anything on Windows or Mac. I'll do a Windows video later, but I haven't got a Mac handy to test it. So you can see here what this is doing is it's actually, the green line is the target, and you can see here the target level and where it's actually falling. Okay, so as you can see here, it's actually getting louder up here. Okay. Alright, so that's the ebu-meter. Contact sheet. So the contact sheet generates a tiled image of thumbnails representing the duration of the entire video, and basically it gives you a quick visual overview of a clip's contents, and it allows you to customize the grid layout, thumbnail size, and background color. So contact sheet. Again, Big Black Bunny, contact sheet -H. And what you'll see here is the options. So create an image with thumbnails from a video. And what we have here, the in file, the seek. The default for the seek is set to 5 seconds into the video. And you can override that by specifying 0:0:0:000. And the reason for this is you get a lot of clips that will actually fade up from black. And to avoid a black screen in the first thumbnail, we set it to a default of 5 seconds in to emit that black frame. But again, you can override that. We have the width of the thumbnails, which is default of 160. The layout, which is like which by default is a 4:3. We've got padding, we've got margin, we've got color, font color, box color. Timestamps, so this will display timestamps on the video, and a -J option to specify either JPEG or which is the default, or a PNG, -O for the out file, H and V for help and version. So what we'll do is run contact sheet start in Big Black Bunny, and let me just refresh my memory. So what we're going to do is we're going to use the -T option to set a 8:8, and the -X option with on to add timestamp. So we'll add -T 8x8 -X on, and what this is going to do is it's going to create a file which has the duration of the video as well as any options that you've passed to the script. So this has to read the entire length of the video. So as you can see there, we've got the big Buck Bunny contact sheet. Didn't actually, I thought it would add the options. Maybe I'm mistaken, my memory's fading here, but you can basically see it specified the start time and then the end time of the video. So if we come into the contact sheet and open that up, what you'll see here, start time, end time, and because we use the -x option, what we have here is timestamps for each of the frames. And as I said, you can specify not to have the timestamps aren't the default. You can change the tiling, you can change the color, and the actual grid, basically how many, you know, whether it's 4x3, 4x6, or whatever. And again, that works with FD as well, so you can create multiple contact sheets for all of the videos in the directory. So the next one is chapters and metadata, and what this is this is how you can actually add chapters to a video without actually re-encoding it. And what it does is it uses two scripts, chapter-csv and then chapter-add. So what we have here is a text file. It can either be a text file or a .csv extension. And what we have here is the start time of the each chapter, followed by the title. And what we have here, this is the end of the video, which is 10 minutes. And what we do is we put end, but this end flag isn't actually added as a chapter. It's just to let the script know that that's where the last chapter ends. So basically what that means is scene 3 will extend from 7 minutes to 10 minutes. So chapters, I have a chapter-csv file here, chapter-csv, as you can see, using the same timestamps as in the documentation, and I have a 10-minute video. So I'm going to run chapter-csv-h. I just need to give it the input file, which is chapter, and what you'll see here is it creates a new file called chapter -metadata. So it's going to take the existing file name and append -metadata to it and create a text file. Chapter metadata. Okay, here. So this is the format that is required for FFmpeg to create chapters. And what this script will do, if I come down to the next one, so we've got chapter-csv. Okay. And then what we have is chapter-add. So chapter-add takes the text file that we just created, and what it does is it muxes the chapters into the video without re-encoding it. Okay. So basically all we need to do is run chapter-add -i, the input video, -m metadata with the metadata file, and optionally a -o file for option for the custom file name. So chapter-add big Buck Bunny -m, and we want chapter metadata. Bang, that's it, created. Okay, big Buck Bunny, and what it will do is it will append -chapters to the original input file name. So what I'm going to do here is you can actually see these markers, and I think from memory, is it capital? Get what the keyboard shortcut is. What's the keyboard shortcut? But you can see here the chapters. There is a, is it shift? No, not shift. Next, previous. Ah, okay. P. No, I forget what the flipping thing is. Let me have a quick look at the manual. Chapters. There is a keyboard shortcut, but I forget what it flipping is. Yeah, there is a keyboard shortcut, but yeah, I can't remember everything. Okay, so that's the chapter-add script. Okay, there's the help. And what we have here is chapter extract, and what this will do is this will extract the chapters from a video, and let me just remove the chapter.csv, chapter metadata. So chapter extract -h, you give it the input file, an option in the output file if you want. So chapter extract -i, big butt bunny, chapters, bang, less, big butt bunny, chapters, and there you go. It's extracted the chapters just as we added them. Okay. So next script. Oh yeah. What you can also do is you can actually extract the chapters and use them for YouTube. So if you've done a video and used a video editor or something to add chapters, and you want to add the timestamps under a YouTube description for the chapters, what you can just do is run this. So sed let me go back into the chapters. Okay, sed big butt bunny chapters.csv output.text, bang, this output, and you can see here this is the format that would be required to add chapter information under a YouTube video in the description, so that it will actually add chapter markers in a YouTube video. All right. Okay. Okay, subtitle-add. Need more tea. Okay, what this does is this script allows you to softmux external subtitles like SRT or VTT into your video as a proper metadata track that you can use a keyboard shortcut to toggle on and off. So it's not like hard coding the video, which burns the text into the image and you can't toggle it on and off. And again, this uses a stream copying. So what I have here is subtitle. I do I know. CC subtitle. Okay, so what I've got here is a copy of Rubenstein, who's a YouTuber who does really good videos about Newcastle, and I have the video and the VTT subtitles. So
yes guys, how's it going? Welcome back to
okay, so you can see it's picking up the external subtitles here because I have the subtitles file. I run subtitle-add-h. So you give it the input file, which is the video, -s for the subtitles, optionally -l for the language. So subtitle add-i, -s for the subtitles files. It's going to take a second. Bang, it's done. And what I'm going to do is I'm actually going to remove the subtitle file. Yeah. Okay, and you'll see that this should, yeah, so what you can see here, this is added subs to the file name. Okay, so now if I press the keyboard shortcut, you'll see that the subs are now soft muxed into the video. Okay. All right, subtitle add. Yep, you can do batch processing with this. So read documentation using FD. Overlay clip. So what this is it's a script designed for B-roll insertion. So this allows you to overlay a clip on top of your main footage at a specific time while keeping the original background audio playing. So you got, let's come out, overlay clip. So what I've got here is 2 clips. So CD overlay clip. So what we've got here is the first clip, which is from 1:03 to 1:33, and the second clip is 10 seconds. Overlay clip -H. So what you've got is -A for the bottom video, -B for the overlay, and -P for the position, which is the position in the video that you want to start the overlay at. So overlay clip -A, we want the longer version here, -B, the second video, check. Yeah, 45 to 55 is what we want, and we're going to put this in at 10 seconds into the video. So I'll play the original video and then the one with the overlay. Okay. So what you can see here is we have the clip here with -overlay. So that's the clip that it's got the overlay in it. So let's play the 1:03 to 1:33. Okay, so this is the original clip, and I'll play it to the 10-second point. Okay. Right, now what I'll do is I'll play the one with the overlay. And you'll see it at 10 seconds, what will happen is it will overlay a different clip for the duration of the second video. And then once that's finished, it will return to the original video. Okay. All right, the next script, again, there's the help, overlay-pip. So what this is picture-in-picture. So let me come into here, overlay-pip. What I've got again is the same 2 clips, overlay-pip-H, and we have similar options. We got -A, -B. So the bottom video, the overlay, the position to start the overlay, and got margin. So picture-in-picture is like a little picture-in-picture that appears while the video is playing. So we've got the position, the margin, the X position, so top left, top right, bottom left, bottom right. We've got the width, which is default 1/4 of the video. We've got the fade duration. We've got a border. You can either have a border of 4 pixels, which is the default, or 0. And the reason for that is because it's basically the maths that it's impossible to set something. You can't set 2, because if you do, it cuts off the border, basically. And you can specify the border color. So what we'll do is run overlay-pip -A, the first video, which is 30 seconds, and the second one's 10 seconds. So 03 -B, second video. Yep, the second video. The position, we basically want to set this to be 10 seconds into the video. And we'll use the default options. Yeah. Okay. And what you'll see here is we have a file with the original file name -pip, and what it's actually doing here is it's actually specifying the position here and the duration. So it actually outputs the options that you have used on the command line in the file name. So 10 seconds in, it will put the picture-in-picture in. And the picture-in-picture will last for the duration of the clip that you have passed in for the picture-in-picture, and then it will vanish. Okay. So those are the options that you can use. There's the help. Next one we got is fade clip, and what this does is this fades a clip in as well as the audio. So let's come into fade clip. Okay, so we've got Big Buck Bunny here, and this is a 10-second clip, is it? 30-second clip. Okay, so fade clip -h. In file, the duration, the options that we've got. So the default is half a second, but what I'll do is I'll specify 2 seconds so that it's more obvious. So fade clip -I. Big Buck Bunny, duration. Okay, that's a 30-second clip. And what you'll see here is faded in and the duration that you specified. Okay. You see that? That's fade in. Again, you can batch process using FD. Okay, xfade, you're going to like this one. So the xfade script creates smooth transitions between two video clips, and it provides a xfade filter for video and a cross filter for the audio simultaneously, ensuring a professional audio video blend. So if you have a look at the xfade section of the FFmpeg wiki, these are all the fades that you can actually use with this script, like fade to black, fade to white, distance, white left, up down, slide left, slide down, move right, circle crop, rectangle crop. I think I've covered all of these. I'm not sure if they added extra ones since I originally did it. If I've missed any, then I can always add them. So xfade, cd xfade, xfade-h. Okay, there's the list of the transitions that we can use and the options. So we got -a for the first clip, -b for the second clip, -d for the duration, -t for the transition, and the basically the offset's calculated automatically between the two, but you can override it. So let's do xfade-a clip A. I named these ahead of time. -b clip B. And what we're going to do is we're going to specify a duration of, let's say, 2 seconds. And what we'll do is use the circle crop transition. It's quite a good visual. Cue. I'm not going to go through all those transitions. I'm just going to show you one. I'm just going to have some more tea. Obviously, the two clips have got to be long enough to actually support the duration between the two of them. So what you'll see here is clip A, xfade, circle crop, and the duration. We've got to wait till the middle of the clip. Okay, you see that? Quite a good one because it pulls back onto him. So that's how you can add a transition between two clips. Okay, there's the help. Okay, next one is pan scan. So this animates a static image by panning the camera across it in a specified direction. Automatically handles the scaling and cropping math to ensure the movement is smooth and the output matches the original image's aspect ratio. So what we can do is use the -P option with left, right, up and down with L, R, U and D. So pan scan, and what we have here is just a static image from Big Buck Bunny. We want pan scan -H. Give it the input file. We'll give it a duration of say 5 seconds. Position. So let's say we want to pan left. So we do PL. And so what it's going to do is going to create a 5-second video that pans the camera to the left. And as you can see here, again, we have input pan left and then the duration so that you can see here the image is panning left, 5 seconds. Obviously, if it's shorter, it's going to pan faster. Okay. And you can batch process stuff with that as well. So next is zoompan, and what this does is it converts a static image into a video clip by applying a Ken Burns style zoom animation. And to prevent jitter, what it does is it uses high resolution input scaling before applying the movement. Okay, so these are the options that we have got. We got the zoom either in or out, and the position, so center, top left, top right, bottom left, bottom right, top center and bottom left, and that's C, TL, TR, BL, BR, TC and BC. So coming to the zoom pan script, again the same image. Yep. Zoom pan -H to the options. We want to give it the input file. Oh, just zoom pan -I, the input. We'll give it a duration of, let's give it a longer duration of 10 seconds. We'll zoom in and we'll position center. This is going to create a 10-second clip that's going to zoom in to the center of the image. More tea. Oh, it's getting a bit cold. Okay, so this is chundering away, and the reason it takes a bit of a while longer is because what it does is it does some maths to actually scale up the image before it processes it, so that you actually get a smooth transition when you're applying the effect. Okay, there we can go. And again, all the scripts provide FFmpeg output, so you can see the script's not just hanging, it's actually doing something. Okay, and what you can see here is the actual time. So because this is a 10-second duration, I need to waffle on for a bit to fill the dead air. So again, you've got multiple options, zoom in and out, and the position in the image you actually want to zoom in or out of. And this is basically a Ken Burns effect. And Ken Burns was is rather a guy who did a lot of documentaries, and he used this technique a lot in things like Civil War documentaries, kind of zoom in and out of images, of static images, to give the images a bit more motion and a bit more life. So you can see here we're 6 seconds in. Obviously, the shorter the duration, the quicker it's going to process. But I just set the duration for 10. So you can see input zoom in center 10 seconds. That tells you what options you actually used. You can see this is gradually zooming in. You see it's nice and smooth, no jitter. You get the idea. Okay. So zoom in, that also has support for batch processing using FD. So conversion and extras. So audio silence. What this does is this replaces the audio in a video clip with silent audio. It keeps the original video stream without re-encoding, and it generates a silent AAC audio track. And this is useful for clearing the audio or adding a silent track to a video-only file to ensure compatibility with players that require an audio stream. Audio silence, Big Buck Bunny, audio silence, -H. The options you've got are channels, mono or stereo, defaults to mono, defaults to 44, 100. But you can override those with the -C or -R option. So we can just give it the audio file, audio silence, -I, Big Buck Bunny, bang, done. You can see here, Big Buck Bunny -silence. And that's the sound of silence. So again, that's useful in some cases when you want to clear out the audio or add a silent audio track to an existing video. Okay, and that also supports FD batch processing. Okay, extract frame. The extract frame script saves a single clip from a video as a PNG or JPEG. The default's JPEG. So you can also specify the actual size, so you can actually specify you can cross to extract CD extract frame. Again, Big Buck Bunny. Okay, extract frame -H. Start time to extract the frame from, the input file, the format. Default is JPEG, or you can specify PNG. You can specify either the X or Y coordinates, so that's the width and the height. So you can specify both of them together, like you know, 1280, 720. But if you only specify one, it will work out the other one and retain the aspect ratio. So what we'll do is we'll just give it the input file and a timestamp. So extract frame -I, Big Buck Bunny, and we'll just choose an arbitrary time of 5 minutes 43. Bang, done. Okay, so let's come across here to extract frame, and there we go. There's a little mouse before it's going to get clobbered by Big Buck Bunny. And again, you can specify PNG, and you can specify the height and the width. And again, this also works with batch processing using FD, so you can process all the MP4s or MKVs or whatever to extract the frame from the video. And there's the help. Okay, image to video. So this converts a static image into a video file with a specific duration, and it creates a H.264 file, 30 FPS, YUV 420 pixel formatting, ensures it plays on all devices. Okay, and this is useful if you want to turn a image into a video, because you can use FFmpeg to concatenate lots of files like video files together, but not images and video. So this allows you to splice together lots of video files and images that you've converted into a video. So CD image to video. What we have here is the same still. We run image to video -h. We've got the in file, the duration, and optionally an output file name. So what we'll do is image to video, give it the input file name, and we'll give it a duration of 5 seconds. Okay, there we go. Input and then the duration. And as you can see here, this has just created a video file, which only has a video track, as you can see. And so this is where you might want to use the audio silence script to add a silent audio track to it, so that you can actually use it with FFmpeg concatenation, so that you can concatenate it with other videos, because when you're using FFmpeg concatenation, there are two types, but the typical one I use actually requires all the videos to be exactly the same, have the same codec and audio channels and that sort of thing. Right, and again, this works with FD for batch processing. Sexagesimal-time. Okay, what this does is this calculates a precise duration by subtracting a start time code from an end time code. This is designed to help determine the exact length needed for trimming audio and video files with FFmpeg. So in this example here, we've got start 1 minute, end 1 minute 45.500. So if we come across in here, run that, it will spit out the exact time here. Yeah, and this doesn't have any external dependencies, it's pure Rust math. Okay, so that's basically helps you calculate durations of the clips when you want to cut stuff up with FFmpeg. Okay, vid to GIF. Okay, so this converts a video file into a high quality GIF animation, and what it does is it uses a two-stage FFmpeg process. It first generates a custom color palette from the video, and then applies that that palette to the final GIF, and this prevents the dithering or color banding issues commonly present in standard GIF configurations. And what you want to do is actually trim a clip beforehand for the length you want to do. So what I've done is actually done that. I've created a clip with one of the trim clip scripts. So vid to GIF, and what we have here is MPV Big Butt Bunny clip, which is I think 10 seconds long. Okay, so that was 5 seconds roughly. So vid to GIF-H, and we give it the input file. We can specify the width and the FPS. So default is 320, so let's just stick with the defaults, but you can override those. Okay, there we go. Can't remember if okay, yeah, you can see there. So that was a small one. Let's do it again with the bigger size. So let's do width 640, width 640. It's overwritten the previous clip. So yeah, that's something I should have taken into account. So just bear that in mind. So there's a bigger clip. You can see there's no kind of banding issues. So it's, there we go. So that's maybe one thing on my to-do list. The vid to GIF. Yeah, you can do batch processing. Just make sure these obviously the files won't have the same name. Okay, WebP. So the WebP script converts the video into an animated WebP image using FFmpeg. Animated WebP files often provide better compression than GIFs, while supporting a full range of colors and transparencies, making them ideal for high quality web animations. So same kind of deal. So WebP, what we have is the exact same clip here, just for consistency. Okay, so WebP-H. So let's give it a WebP-I, and let's create the width, say 640, and the FPS, let's do 30. Okay, can't remember if this plays WebP files. If not, you can use the browser. Okay, so MPV doesn't play the where's the WebP? Okay, Firefox should be able to play it. So you can see there, that's looping. All right, so that's WebP. Again, supports batch processing. Okay, scene detection. So what we've got here is a couple of scripts. We've got scene detect auto, and this automates the entire process. So that basically all you just do is run scene detect auto -i and give it a file. What it does is it automates scene detection and video splitting. What it does is it combines the three following scripts: scene detect, scene time, and scene cut, that I'll show you in a second. And what it does is it creates a large number of files, so it's best to actually create a directory for the video you're going to process, because it can create like hundreds of files. And what it does is it splits the video depending on a threshold that you can specify every time the camera changes. So I've got instructions here on actually how you create the directory, and with Windows PowerShell as well. So basically you just run scene detect auto -i input, and what I've done, because this takes a little while to actually run, is I prepared the thing ahead of time. So what we've got up here is Big Buck Bunny, and what it's done is it split the video into scenes, and you can see scene 1, 2, 3, 4, 5, and it will actually provide the timestamp. So 0 to 11 seconds, 11 to 15, 15 to 23, 23 to 47. And if I come to the bottom here, what you'll see is we have two text files, detection and then cut list. So detection is the position of all the timestamps. This is all the scene changes, and the cut list is the format that is actually used by FFmpeg to cut the video into bits. So come on, scene detect. Oops, scene detect. Okay, MPV bigbuckbunny.mkv. Okay, so here's the first clip. So what I'll do is I'll just play the first couple of clips. So now there's the second clip. There's the third clip. The Big Buck Bunny -001. This should give you an idea of what I'm on about. So there's the first scene. So it basically splits the video into scenes. Okay. MPV Big Buck Bunny 002. Scene 002. There's the second scene. MPV Big Buck Bunny scene 003. There's the third scene. Okay. So that's scene detect auto. You just run scene detect auto -i, give it the file, bang, Bob's your uncle, chop it up. You can specify the -t option for the threshold. which is how it determines the scene change, the sensitivity. Okay, so what we have here is the manual version. So you can do this manually as well by running these 3 scripts one after another: scene detect, scene time, and then scene cut. So you can read the documentation here for that. So I'll kind of whiz through that. Okay, scene images. What this does is this creates images for every cut point in your cut list. I don't know if did I create a scene. So we've got the cut list here. So let's do the cut list. So scene images -h. So we just give it the input video file. So we want to actually make the directory clipped, and then move Big Butt Bunny -scene into clips. Bang. So we should just have Big Butt Bunny there. We want to use the cut list. So scene images -i -h. Push my memory. So default is JPEG. You can use the -t option to specify PNG. Then you've got the -x and -y options to specify the width and the height, either together or individually. So scene images -i Big Butt Bunny cut list. So that's the cut list. And as you can see here, what it's doing is it's taking that cut list and it's going to create images for each cut. And what this is useful for is creating images of all the scene changes in a video, so that you can actually visually see, using images, all of the cuts in a video. So there's quite a few. There we go. Bang, job done. And you can see here scene 1 all numbered sequentially, and then the timestamps. And if I come back in here, come to the first one, black. Yeah, you get the idea. Okay, so that's scene images. Okay, so that's all the script. So what I can do is actually go through the source code. This section down at the bottom here, this is for me. This is how I actually build the project. So what I'm going to actually do is come up and show you the source code. So what we got here is these files. We've got the cargo toml, we've got the license, we've got the flake.nix. So this is basically, this is the flake that I use on NixOS. And what this allows me to do is actually in the terminal, I can run nixdevelop, and what it does is it creates a Rust environment with everything set up so I can build the project. And I got a few tips from Vim Joya's YouTube channel about this, but I had to do some additional work. What you can see here is targets, muzzle, and Windows GNU, and this allows me to build on NixOS for Linux and for Windows as well. Okay. All right, and then what we have here is the cargo toml. What this is the package. What we have here is this librs, and what I've done is a lot of the scripts share the same functions. Okay, so rather than actually having the same code repeated all the time in the scripts, what I've done is I've extracted it into this librs file, so that it's actually shared. We then have a list of all the scripts down here, bin. So these are all the scripts. And you can see here, this is the dependencies that are required. Okay, then what we have here is the source directory. Okay, so this is the librs file. So what we have here is the header, the version, and what we have here is all the libs are named like lib1, lib2, and what we have underneath is the scripts that actually use this particular function here. And this is so that I can see in the script, let me come back out, show you a second. So these are all the functions, okay, like lib2, lib3, so I can actually see which script uses which functions, okay. And if I come across into one of the scripts, what you'll see is up at the top, we've got the name of the script, the description, and the reference. So it actually tells you which functions are used in that librs file for each script. Let me find a more interesting. Let me find the trim clip 2, for example. Okay, so clap is basically like get ops in a shell script, is what provides the options to the script, like -h, -v, -i, whatever. This is how we create the help. So this is the help section. These are the arguments passed to the script, the main body of the script, how we format stuff, how it checks for file extensions, and the actual FFmpeg code down here, as you can see. So these are the different commands that can, kind of different functions for the supported files. These triple comments are basically like doc strings. So double comments, double slashes are comments, triple are sort of doc strings. Okay. So that's just a sort of overview of the project, and I'll just scroll down to the bottom. And as a tip, what you can actually do is, if you see this section here, this actually shows all the headings in the file. So I can say build. So if I want to jump to this section down the bottom, I can do that. So just click that there, and you can easily search for stuff. So this is how I sort of build the project, create a project directory. There's the flake.nix. I run nixdevelop, and so for NixOS, I just run nixbuild. It builds everything. And copy the binaries it creates to the build directory on the desktop. For Linux, I run cargo build. I run nixdevelop, cargo build, release, target, muzzle, and for Windows, I run Windows GNU. And this is basically my notes, as I said, on actually building everything. And what I'll do is I'll just show you the actual build directory projects FFmpeg Rust script. So results, this is the directory where it builds everything for Nix. Source is, we've got the main here, and what this does is basically a file that I don't include because it's not needed. It's just basically the main file that lists all of the scripts and the categories. We've got the librs, which I showed you. And then we've got the bin directory, and these are all the files with the .rs extension, which are the Rust files. And then we've got the target, and what we have here is the muzzle. So these are the built Rust scripts for Linux. And as you can see here, these are all the executable files for Windows. So for Windows, we have .exe files. Okay, so what I need to do in the next video is actually take you through setting this up on your operating system. So NixOS, Linux, Windows, Mac, and FreeBSD. What I'll do is I'll just take you through the instructions on these NixOS and Linux and Mac OS X and FreeBSD by showing you the README section and going through the relevant points. On Windows, what I'll actually do is I have a virtual machine set up so I can actually outline the process of actually getting them installed. I haven't installed anything on Windows yet, so touch wood, everything works, but hopefully it should. So that'll be for the next video.